This is the Geometry Concepts section on tangents and segment lengths. So we're going to look at a few scenarios that are pertinent to this section. First one, if I have a point outside of a circle, we'll call that point A. From this point, there are two segments that are tangent to the circle. I can draw a tangent going up here to the top. I can also draw a tangent going down to the bottom of the circle. And we have our two tangents. Now, tangents can be lines, segments, or rays. The important thing is it could be turned into a line, but I'm only going to focus on the segment part. And the first theorem we're going to look at is that these two tangent segment lengths are congruent to each other. In other words, the length of segment AB is equal to the length of segment AC. Next, if we have a tangent segment and then the radius drawn to that point of tangency, what we know is that we have a right angle. If I want to draw a segment coming from this point outside of the circle to the center of the circle, then we've created a right triangle. And some of the problems you might be seeing involved could look something kind of like this. So if we know this length is maybe 4 and this length is 3, then we could use Pythagorean Theorem, 3 squared plus 4 squared equals 5 squared. So then the length of this hypotenuse, or of this segment, would be equal to 5. Another type of scenario you might see is something like this. So the circle is inscribed inside of the triangle, and we have these 3 lengths of segments that are tangent to the circle, and we're going to be asked to find the length of this value, x. To begin with, we have to remember the fact that from a point outside of a circle, the two tangent segment lengths are congruent. So since this segment is x, that means that we have another length of x also. Furthermore, since this length is equal to 12 and this part of it is equal to x, the remaining part then has got to be equal to 12 minus x. And for the same reason that I just mentioned, from a point outside of a triangle, those two tangent segment lengths are congruent to each other. So since this top length is 12 minus x, this other length is going to be 12 minus x also. So we can label this one also as 12 minus x. And what we've done is we've started at this point and we've walked halfway around the triangle going in that clockwise direction. We're going to do the same thing going in the counterclockwise direction. And then since this entire length is 14, this part of it is equal to x. That means that the remaining part is going to be equal to 14 minus x. From a point outside of a circle, those two tangent segments are going to be equal to each other. So since this one on the left is 14 minus x, this one on the right is going to be 14 minus x also. So I can put in, for this length, 14 minus x. So what we've done here is we started at that point, we've walked around the circle counterclockwise halfway to also get to that same point. The important thing here is that this segment hasn't really been used yet. What we know from the given is that the length of this segment is equal to 13. It's also made up of these two parts that are 12 minus x and 14 minus x. So if we add those together, 12 minus x plus the 14 minus x, that's equal to the given length of 13. Now, if we do a little bit of algebra on this one, combine like terms, 26 minus 2x is equal to 13. Subtract 26 from both sides, and now divide both sides by -2. We get that x is equal to 6.5. So what we were looking for was the length of x, and x, this segment, is 6.5 units long. This is another potential type of problem that you might see. Let's say that this central angle is 70 degrees, and we want to find the measurement of this angle outside of the circle. Well, we know that since we have a tangent segment and a radius, they're going to intersect at a right angle. So then inside of this triangle that we have, we've used up 90 degrees plus 70 degrees. So take 180 minus the 70 minus the 90, and we have left 20 degrees for the angle that we were looking for. This is the last problem that we're going to look at. We have a tangent segment, we have a radius drawn to the point of tangency. So once again, we know that this must be a right angle, and we're trying to find the length of x. Because it's a right triangle, that means that this turquoise triangle is a right triangle. So we can use Pythagorean Theorem. X is one of the legs, So x squared plus this other segment squared is equal to the hypotenuse. Now the hypotenuse is 9 plus 32, so that's 41 squared. The only question is, what is the length of this other leg in the triangle? Keep in mind that in a circle, the radius cannot change, so since this radius is 9, this radius is 9, and that's the other length of that side in the triangle. So here is our Pythagorean theorem. X squared plus 81 is equal to 1681. Subtract 81 from both sides. Take the square root, and x is equal to 40 units.